Hello everyone, I'm Mark. I'm a senior software engineer working at HMRC on the tax platform project. I'm on Twitter if you want to say horrible things about me, and of course the presentation. And I'm going to talk a bit about property testing, which is a technique we've been using over the last few months, bits of, and have found reasonably useful. So I thought I'd come and tell you all about it. I'm going to run through some examples of where we found it useful. Talk a bit about a library that we're using to do it with, and the sort of features that I think are useful in any library that you want to do property testing with. Talk a little bit about state-based property tests, but not very much, and then I've got one or two conclusions, and then I'm done. So some examples. First example. So HTML has a wonderful label thing that I think they introduced in HTML5, where you can click on the label and it will jump to the input. And then you can start typing your name or the amount that you need to pay, whatever. And that's great. There's a tiny problem with it, in that if you make a mistake with when simple typo, then it just doesn't work. And it's nice to, well, so this actually happened, and we didn't catch it. We didn't have any tests specifically asserting that there was a label and it had the right ID and it had the right for field. And in the end, what caught it was manual testing. It didn't reach the users, but it also got further than we'd like. I like my manual testers to have a very boring life, and they like to make my life more exciting, and they won that time. So we have a regression test for it to sort of try and prevent it happening again. Only that's kind of dissatisfying. We've got the ID in twice. If we want to change it for some reason, if we start generating them automatically, we're going to have to change this test. It's kind of brittle. You could imagine it might start to pass spuriously. It might really be failing, but there might be some other things on the page that might cause it to pass. It's not very satisfying. So there's a library called JSoup, and then what we have is something that runs to CSS selectors, pulls out all of the text fields, and says for each of them there should be something in the page that is a label for that input field. And that's a property test. That's saying that the page, there's a property on the HTML page that we're rendering, that all of the input fields that are of type text have a label and have the right ID on that label. And so that stops not only that specific example from going wrong again, but any of the other ones we've got on any of our other pages from suffering from the same problem. So a second example. This one's even simpler. So we render money. We render money all over the places. It's a tax platform. This is an example of a summary halfway through the payments flow. We render money, and we render it in the same way that we've been writing it, I imagine, in the UK since we were school children. The problem is, if you enter it that way, then it doesn't work. Or in the initial stab, the minimum viable product, it didn't work. And that's sort of all right. It's a bit inconsistent, but it's okay. Except that we've got two fairly large disconnected bits of the tax platform, and at some point, in order to get something online for users to use, we've asked them basically to write stuff down on one website, part of the website, and type it back in another part. And I think a reasonable thing for them to do in that situation is copy and paste. And that doesn't work. And leads to a fairly terrible user experience. And we have user testing, and that was part of the feedback. So we put in a feature to parse a nice pound sign, to parse that thing into an actual amount. And then there's a few, we have some tests for it. There's a few things to test. But but when you sort of start to add them up, you know, we want to test each of those things, so that's 3 tests. We want to start testing, to be really sure, we'd like to test combinations of them, so a pound sign and some white space on either side, which you get when you copy and paste. We might like to test so that's 3 combinations of 2 features. There's another test that we might like to write that has all 3 of those things. We might like to write a test that has none of them. So we're sort of up to 8 tests. And then there's a trade-off, because that's quite a lot of tests, and they are an effort to maintain. And so perhaps we trust that after only 3, that's okay. Alternatively, we could do that, which is a single test which generates 100 or so. I mean, don't get too dragged into the syntax of it, but it generates some padding, it generates a pound sign, it generates an amount, and some commas, and they're all optional, so they'll either be there or they won't. And the amount will be sort of anywhere between a penny and 98,500. And then we create a string that looks like that, and we say that should be valid, that the validation on the form that uses that regular expression should work. And that's another property test, and it replaces all 9 or so, or the confidence that all 9 or so of those other tests that I listed would have given us if we had them all listed out manually. So then the third example of a place where we found it useful is every user of the system has an identifier. They are of a particular format. They need to be 11 characters long. They need to pick one example, they need to end with a K. And they also need to checksum. So 2 of the digits at the end are a checksum. The rest of them, there's an algorithm that gives you another 2 digits, and those 2 need to be the same. We've got performance tests to exercise the system. We want to exercise it in as realistic a way as possible. And in order to do that, we need a lot of identifiers. And all of them need to be unique, because when people log into the system, we'd like to simulate lots of different people logging in at different times and doing different things. We can't really test that something is generating unique values by looking at a single value that it produces. So we wrote a property test. We generated 500,000 of the things. We said all of these things should be valid tax identifiers, and none of them should be the same as each other. And then we were confident that our performance tests weren't repeating the same user. And finally, a slightly more involved example for a V80 reference. So here's one of those tax identifiers I was talking about earlier. It's sort of a simplified example, in that the real one is longer. Here are some weights that we want to multiply each of the first 5 digits by. Here is the weighted sum that we're going to produce. The next step of the algorithm for VAT identifiers is you have some limit. Whilst the thing is greater, the weighted sum is greater than the limit, you subtract 20. And then your final checksum should be 20 minus the value you get, which is 17 in this case. So I think that there's a certain kind of brain that looks at that minus equals and says, that's a modulus, isn't it? Yeah. Specifically my kind of brain. Unfortunately, well, no. And so we have some examples, and the green ones are valid VAT identifiers, and the red ones aren't valid VAT identifiers. And if you just naively replace the minus equals with a modulus, these will pass. Fabulous. Push it to production. And now I'm going to try and demo something, which I'm sure is going to work extremely smoothly. Well, not at all. And then we're going to do this. Can everyone read that? Fabulous. So here are 2 different implementations of the same algorithm. One of them is exactly as I showed you, with the minus equals 20 and the while product sum is greater than 20. And, oh no, one of them's with the modulus, sorry. And the other one is in the property test, and it has the loop and the minus equals 20. Yes, what's happened here is I've not deleted that one. So this is actually a property test written in Scarlett Check. We have a very simple generator that generates lists of 5 numbers, which maps back to the identifier I showed you earlier. And so we can run this. Look at that, it worked. And what it's done is generated us an example of a 5-digit list which fails, where the two aren't equivalent. Did anyone spot why?
Yeah. It's greater than 20, so there's an off by 1 error. If you take a modulus, you always get a number between 0 and 19.
It's a similar edge case, but not exactly the same.
No.
But yeah, that sort of thing. On the exact boundary, you end up with a different answer from the modulus than you do from a repeated minus equals. Here are some more examples, just in case the demo didn't work. So those are some examples of places in HMRC where we found property testing useful. Does that seem reasonable? I mean, are there any questions about those? Was anyone sort of looking at that and thinking, you've gone completely the wrong way, here are some simple examples where you know, an example-based test would have given you the same result, the same confidence? Good, I shall carry on. Or I won't carry on, because I've clicked in the wrong place. There we go. So what is property testing? Example-based testing, which is sort of what I've been doing since I've been thinking about tests, it shows how a single input to the system, and that might be sort of setting up a bunch of bits of state and then calling some part of your system, relates to a single output. And you can express that in code or in text or in table or a spreadsheet, and you can have lots of them all sort of pressed together. And then often you want sort of 1 or more per feature, and you often want 1 or more per inverse of feature, and you often want 1 or more per interaction between features. And that's how you build up confidence that your code does the right thing. So for example, there's a grand tradition of talking about reversing strings when introducing property tests. So this is how you might do it with 3 examples. And then a property test is a property theory statement or claim about the behavior of a system. And I think that you have to express it in code. I've certainly not seen a way to express it in text yet. And you verify it at test time. And I think it's important because everywhere I've seen property tests used, people are talking about the generators and the random data that you use to feed in. I think it's important that it doesn't have to be about, it doesn't have to involve randomly generating data. You can exhaustively test parts of your system, and that's a property test. You're testing a property of the overall system, and you're doing it exhaustively, so you should then be very confident that it's doing what the property expresses. So let's take the string demo. Back here again. This time I want this one. Nope. Wrong keyboard shortcut. So I found a Java property testing library that it looked like someone had knocked up in a weekend, but worked perfectly well. So here is a method to reverse a string in Java. I'm not 100% sure it works, but then I'm the one that put it there. Here are some properties that we might expect to be true about that string. We might expect that if we reverse it twice, we get back to our original string. That if we reverse it, it has the same length, and then we might expect that if we iterated through the string one way and we iterated through the reverse string the other way, they'd have the same characters. And we can run this. And it tells us that if we put 10,000 strings into each of those properties, they all pass. And if we come back up here and we, I don't know, we break it by getting rid of this minus, then it will tell us that for this string, one of the properties failed. Specifically, the reversed string wasn't its own inverse. So then that's given us sort of 3 tests, which I think gives us a lot more confidence in this implementation of reversing a string than 3 checked examples, whilst being slightly more complicated. Does anyone think that's actually right at this point? It doesn't work for Unicode strings. That's the implementation of string reverse that's in String Builder, and I stripped out the Unicode handling. So Scarlett Check is a library written in Scala to mirror some of the features in Quick Check, which was originally written in Haskell, and now all the interesting stuff is going on in Erlang. The idea is that you can't exhaustively test every system. I mean, each int alone has that many possible values, and as soon as you start adding more things, the number of possible values goes up as the exponent of the number of things that you've got. So Scarlett Check gives you facilities to build random generators for test data. Once you've started building those, it gives you a way to constrain some of the values that you're generating. So you can sort of say, all right, I want strings, but I want strings that are above a certain length. And that's a way to quickly generate generators from existing ones. And it gives you the opportunity to shrink failing tests. So as soon as you're randomly throwing input at a system, the example string that failed the string property test was huge and was full of garbled mess. And that looks very noisy, and it can be difficult to see what's going on, and if you try and debug, it's difficult to step through. So shrinking is a technique for taking a large thing that you already know fails, and applying transformations to it that you believe might be failure or success preserving, and rerunning the test with that new input. And if it still fails, then you carry on until it stops failing, and if it doesn't fail, then you try something else, or you stop and you say, okay, this is the smallest example I can find that still gives us the failure. And so it helps you find the signal in the sort of the random noise of your test data. It also lets you label the data. So I found uses for constraining and shrinking examples. I've not managed to find a use for labeling. You can say that part of the data you've received belongs to different categories, and then you can get it to print a distribution afterwards, which might be useful. So it also has a state model-based checking library built in that came in the most recent version. So there's a few presentations floating around of people using this, and I got quite excited by it. So and started looking for places we could use it at the tax platform. I haven't yet. The most exciting one is a presentation by John Hughes called Quick Checking React, during which he talks about a spec that they built of property tests for LevelDB using the Erlang Quick Check implementation. They found a minimized sequence, so they tried to shrink it. The algorithm tried to shrink it as much as possible and couldn't get below 17 commands on a database. That caused a failure in the system, which led to a bug being fixed in the underlying software. They then reran exactly the same spec and found 33 commands that generated exactly the same failure. And then they had to go back to the original spec for LevelDB, the original requirements, I guess, to actually work out what the cause of that failure was and fix it. So that sounded good to me. I think that a series of example-based tests give us a lot of confidence. I think they're unreasonably effective, as it were. But I do wonder sometimes if we're sort of leaving black swans kind of floating in the lake, as it were. In that the failures you then leave are the ones that are very, very hard to find and very, very hard to test for, and the kind of thing that unfortunately users tend to trip over when they're doing unreasonable user things. So that was interesting. And then there was a follow-up blog post from that called Quick Checking Poolboy for Fun and Profit. He claimed that Poolboy had 85% test coverage. It was a library he'd written to support React. And he claims that the remaining 15% was irrelevant boilerplate. They found, by building a property test-based spec for it using the state machine stuff, they found a number of bugs in the system that weren't covered by the unit tests, all of which carried on passing after they'd fixed the bugs as well. I emailed him to find out whether they'd built the system using TDD, because I was interested, and I think probably not from his reply, but he didn't.
Was it printable?
It wasn't. Oh no, yes it was. I don't think I'm going to demo that in the time that we've got. So I had some very brief conclusions based on how we've approached this. So all of the ones I've written, I started trying to write them first and quickly got lost in generating different test data. It didn't work terribly well for me. So I used example tests to build the system and then wrote a property test afterwards and sort of tidied up some of the example tests that I thought were covered by the property test. I had a conversation with a colleague where who's also been writing these, and he said it was, well, he all of the ones he's written have been written test first, and what he's done is built up the test data that's generated using the sort of red-green cycle. So he starts with some very simple test data, runs the test, sees that it's red, goes and writes a little bit of code to fix it, and then makes the generator more complicated, adds another possibility, adds another option, that sort of thing, and does the cycle that way. He said that was very effective. We have, as I said a second ago, we have refactored some existing tests to property tests to try and make them more maintainable. We haven't found them to be terribly good for communication. Certainly, we can't show people the Scarlett Check thing I showed you a minute ago, but we're doing BDD, so we try and get our product owner and QA involved in spec writing sessions, and with the current product owner at least, we haven't found a way to sort of get him to express properties about the thing he wants to build that turn out to be true. Which is one of the reasons that example-based tests are useful. Property tests do help you find out where the flaws in what they've told you are true. Our previous product owner used to make sort of big sweeping statements about what he expected the system to do all the time. I don't know if it would have worked any better with him. So I think there might be an aid to communication. There's certainly an aid to helping you find specific failing tests, but if you can find those just by talking first, that's probably better. Yeah, I mean, you could imagine writing that, but we actually haven't. So then, the concrete places that I would suggest that if you find yourself writing something using regular expressions, something where you have multiple implementations, you've either rewritten something to make it faster or add extra bits of functionality, but you want to be sure that you're still covering the same behavior as your original implementation, or something where you've got highly structured output like HTML. There are a number of properties we've talked about testing for on our web pages that I think might be true for any web page. So all of the classes that you're actually using in your HTML should be defined in a CSS file that it includes, that sort of thing. Then it might be that property testing is a useful thing to try. Thank you very much.